So just a minute. Hello everyone, I think we are live now. Okay, so this is the lecture 10, lecture 11 I think of our LPP lecture series. Okay, so in the last lecture we discussed the transportation problem. Okay, so in the last lecture we discussed the transportation problem, the starting method, and the one method only, the northwest corner method. Okay, so in this lecture we will discuss the transportation problem and three methods for solving of transportation problem. First one is row minima method, second one is column minima method, and third one is matrix minima method. Okay, so let's start, and before starting I am requesting those who are new in my channel, please like the video, comment if you have any doubt in the comment section below, and subscribe the channel. Okay, so let's start with row minima method, and the lecture link, the previous lecture link also available in the channel. Okay, so you can check the description for the playlist of LPP lecture series for GATE and CSIR NET and any state level set exam. Okay, and you can check also here in the I tab. Okay, so see, first we comes to the row minima method. The steps for the row minima method is here given by the steps involved in the determining as initial basic feasible solution using the row minima method are as follows. Okay, step 1 is write the given transportation problem in the tabular form if it is not given. Okay, step 2 is determine the cell with minimum cost in the first row. Okay, so the name, from the name you can guess that what types of method this one is. Okay, so determine the cell with the minimum cost in the first row. If it is not unique, then one of the cell of the first row with minimum cost can be chosen. That means what? That means if there are two cells in the first row which are of same cost, that is the cost of the cells, any two cells are same, then you can choose any one of the cell. Okay, and let it be the ijth cell. Step 3, then allocate x1j is equal to minimum of a1 bj. Okay, in this cell, and a1 bj means what? A1 means the availability from the origins, and b means the demands or destination demands of the destinations. Okay, in this cell, if the minimum of this is equal to a1, then the availability of the origin is exhausted and the demand at the jth destination dj remains bj minus a1. All other cells of the first row will be then unallocated. Okay, if minimum of a1 bj equal to bj, then two cases may be occurred from this and this quantity. The two cases are saying in this step 3. Okay, if this is minimum and this is minimum, then there are two cases. These two cases are available in the step number 3. Okay, then the demand of the destination dj is fulfilled and the availability of the origin 1 remains to be a1 minus bj, and all other cells of the jth column will be unallocated. Okay, then step 4 is what? Step 4 is repeat the step 2 and step 3 until the availability of the first row is exhausted. Okay, step 5 is then determine the cell with the minimum cost in the second row and continue step 3 until the availability of the second row is exhausted. Okay, and step 6 is repeat step 3 continuously until the rim requirement are satisfied. Okay, so these are the methods, you can say. If you are understand the methods completely, then it is well, and if you are not understand the method, then for that we give an example here. Okay, so I think the example is very much important than the theorem. Okay, so see, this is a transportation problem. First you have checked that the transportation problem is a balanced transportation problem or not. Okay, so first just once check if ai equal to summation bj. Okay, so a summation ai means 6 plus 13 plus 9, this is equal to what? 9, 13, 22, 28, and summation bj means what? 7 plus 8, 15 plus 5, 20 plus 8. Therefore summation ai equal to bj. Okay, that means the problem is a balanced transportation problem, and these are the cost. Okay, this cost means what? There is an important thing, that this cost what represent. Okay, this cost represent from origin o1 to the destination D1, the cost of carrying, that is the transportation cost, is 4 unit, you can say. Okay, from origin O1 to D2, the transportation cost is 2 unit. From origin O1 to D3, 5 unit. ऐसे ये चलेगा, ठीक है. Okay, so we have to minimize this cost. From O2 to D1, this cost is 5. From O2 to D2, this cost is 4 unit. Okay, so this is the representation of this cells. Okay, so now first this is the row minima method. Okay, so we have to first find the minimum element in the first row. Okay, so see, the minimum element of the first row is what? The minimum element of the first row is here 2. Okay, so 2 is the minimum element of the first row. Okay, so we allocate this cell first. Okay, this is the x22 cell. Okay, now we allocate here x22 equal to minimum of what? Minimum of this 6 and this 8. Okay, so minimum of 6 and 8, this is equal to 6. So this is equal to, we write here 6, and now the availability for the origin O1 is exhausted. Okay, so 6 is cancelled out, and here the demand for the destination D2 remaining 2 unit. Okay, so this is the first allocation. Okay, now we go to the second row and find the minimum element. The minimum element in the second row is this 2. Okay, so we allocate in this cell, and in this cell means what? This one is x12. Okay, this one is x12, just a minute, x12, and then this cell is the x what? 2 and 4, x24. Okay, so x24 equal to minimum of what? Minimum of this 13 and this 8. Okay, so minimum of 13 and 8, so this is equal to 8, therefore we allocate here 8. Now the demands for the destination D4 exhausted. Okay, since 8 is cancelled here, and here the availability from the origin 1 is remaining now 5 unit. Okay, now we find the next minimum element in the second row. Okay, so the next minimum element is what? The next minimum element is here 3, so we allocate here. So x, this is the allocation cell number x23. Okay, now we allocate here x23 equal to minimum of what? Minimum of this 5 and this 5. Okay, so minimum of 5 and 5, this gives 5. Okay, so we allocate here 5. Okay, now the this cell, or from the origin O2, the availability from the origin O2 is exhausted, and here the destination demands of the destination D3 is also exhausted. Okay, so this is exhausted and this is exhausted. Now we go to the next row, that is the third row, and here find the minimum element, and these two elements cells are already exhausted. Okay, so therefore the next minimum element in the from these two elements, that is x31 and x32, is this 1. Okay, so 1 is the minimum cost here, so we allocate here, that is here the cell number is x31. Okay, so x31 equal to what? We allocate x31 equal to minimum of what? Minimum of 7 and 9. Okay, so minimum of 7 and 9, so this is equal to 7, so we write here 7. Therefore the demands for the destination 1 is exhausted, and here from the origin O3 there are availability of 2 units. Okay, and here only one cell is remaining, therefore we write here just 2. Okay, so this is the answer. So the answer is, the allocations are x212, this is equal to 6. This is the optimal answer by using the row minima method. Okay, so x12 equal to 6, x24 this is equal to 8, x24 equal to 8, then x23 this is equal to 5, then x what? x3 23 equal to 5, x31 this is equal to this cell x31, this is equal to what? 7, and x32 this is equal to 2. So this is the required optimum allocation, and the minimum cost is, the transportation cost that is we minimize here. What the transportation cost is 6 into 2 from this cell, 6 into 2 plus what? 2 into 8 plus 3 into 5 plus 7 into 1 plus 2 into 4. So this is the optimal cost, and if you find this, this is the, I think 6 2s are 12 plus 16 plus 15 plus 7 plus 8 30 30 46 46 58. Okay, so this is 58 unit is the correct answer. Okay, so this is the what, this is the row minima method, that is we first take first row and find the minimum element, then after that we go to the next minimum element if there are any availability or demands from the destination are remaining. Okay, otherwise we go to the next row. So this is the method row minima method. Okay, I think this is now very easy to understand. Okay, now we go to the column minima method. This is the same process, we just apply above method is row minima method, and the same operation holds here in the column only. Okay, instead of row, here the operations occurs on column only. Okay, so now I take the same example. Suppose these are the destination D1 D2 D3 D4, and these are the sources. Okay, O1 O2 O3. Okay, now here the first column is this D1. Okay, so we first find the minimum element in the column. Okay, so 1 is the minimum element in the column, so we allocate here first. So this is equal to x31, which is equal to minimum of what, minimum of total demand of D1 is 7 and total availability of the source or origin or of the origin O3 is 9. Okay, so minimum of 7 and 9, and this is equal to what, this is equal to 7 clearly. Therefore we allocate here 7. Therefore the demands for the destination D1 is exhausted, and here the availability from the origin O3 is remaining 2 unit. Okay, so there are 2 unit remaining, so these are exhausted. Now we go to the next column. Okay, so the next column, in the next column the minimum element is here 2. Okay, therefore 2 is the next allocation cell. Okay, so here 2 in this column, this is what, this is 1 2, so x12 equal to minimum of what, minimum of the availability from the origin O1 is 6 and the demand for the D2 destination is 8. Okay, so this is equal to 6 and 8, which is equal to 6, so we allocate here 6. Therefore what, therefore the availability of the origin O1 is exhausted. Okay, and the what, and the demands for the destination D2 is remaining 8 remaining what, 2 unit. Okay, so here destination remaining 2 unit. Now this is exhausted, this is exhausted. Okay, so next we go to the next this since this column part of this columns is remaining, therefore we allocate here, we allocate we find the minimum of these two, and since these two are the same cost, therefore we can choose any one of the cost. Okay, we can choose any one of the cell for the allocation. Okay, suppose see here we in the row minimum method the allocation is happened here. Okay, so for example we choose this allocation, this cell. Okay, so this is the cell x22, so x22 is the cell. Okay, so x22 equal to minimum of what, minimum of this 13 and this 2, so minimum of 13 and 2, this is equal to 2, so therefore we write here 2, and the demands for the destination these 2 is exhausted now, and here the availability from the origin O3 is remaining what, is remaining 9 unit, I think 11 unit. Okay, so 11 unit is remaining now. Now we go to the next column, the D3 column. In the D3 column the minimum element is now remaining is 3, therefore we allocate here, and here we write x23, x23 equal to minimum of what, x23 equal to minimum of, there is availability 11 unit and there is 5 unit demands for the destination D3, so this is equal to 11 and 5. Okay, so here we write 5, so here we allocate number 5. Okay, and now here the remaining what, the remaining availability for the origin O2 from the origin O2 is what, that is 6 unit. Okay, so 6 unit remaining now, and the demand for the destination D3 is now exhausted. Okay, now we go to the next column. The next column is the minimum element. Since these two cells are only remaining from the allocation, therefore we allocate here, since 2 is the minimum, so we allocate here. So this is the cell number x24. x24 equal to, we allocate here minimum of what, minimum of this 6 and this 8. So allocation is 6 and 8. So this is equal to 6. Therefore we write here 6, and now this is exhausted, and here only 2 units of the demands D4 are remaining. Therefore we write simply 2 here. Okay. So this is the allocation of the column minima method. Okay. So now we find the answer and check. I take this example for what? For to see whether the final answer, that is the optimal cost for the row minima method and column minima method, whether same and or different. Okay. So the allocations are these ones. Okay. I think this is correct. Now the transportation cost, this is equal to what? Transportation cost equal to 6 into 2 plus 2 into 4 plus 5 into 3 plus 6 into 2 plus 7 into 1 plus what? 2 into 5. So this is equal to what? 6 into 2, that is 12 plus 8 plus 15 plus 12 plus 7 plus 10. Okay. So this is the optimal cost. 12 plus 8, 20, 35, 47, 54, and this is equal to 64. So this is the 64 unit. Okay. So see the same problem, we if we solve in the row minimum method, the final optimal cost is 58 unit, and if we solve it in the column minimum method, I think the calculations are all right. You can check it once. Okay. So this is 64 unit. Therefore both the cases for the same problem, there are different answers, and the most acceptable answer is 58 units. Because what? Because we always accept the minimum cost, because we have to optimize, we have to minimize the objective functions here in the transportation problem. Okay. So these methods are initial methods, you can say. You can get a case whether in the column minimum method the cost, optimal transportation cost is minimum, whether the same problem if you solve in the process of row minimum method, then you get the bigger transportation cost. Okay. So this is the case you can get. Okay. So these are, I think here, these are the initial method to solve the transportation problem. In the later of the sessions, we discuss the more improved method of the transportation problem. Okay. So these are the methods. Now we go to the another method, which is matrix minima method. Okay. Now this is also the same method, that is matrix minima method. In the matrix minima method, we find the minimum element from the matrix. Okay. In the row minima method, we should go to the first row, then find the minimum element from the first row. In the column minima method, we should go to the first column first, then find the minimum most element from the first column, and then go to the next columns also. In the row minima method, we go to the next row also, and in this matrix minima method, we find the minimum most element from the whole matrix. Okay. So see here, what? Here 1, see, just a minute. Here this 1 is the minimum most element from the all elements of the matrix. Okay. So we allocate here first. So the allocations is x13 equal to minimum of what? This 14 and this 15. So minimum of 14 and 15. So this is equal to 14. So we allocate here 14, and the availability from the origin O2, origin O1 is exhausted. Okay. And here the demands for the destination D3 is remaining what? 1 unit only. Okay. Now we find the next second minimum most element from the all elements of the matrix, and which is this 2 here. Okay. Therefore we allocate here in this place of this cell, that is in this cost, that is this cell is what? The cell number is x2 3. This is equal to minimum of what? Minimum of this 1 and this 16. So 1 and 16, which is equal to 1. So we allocate here 1, and this demands for the destination D3 is now exhausted, and here the availability from the origin O2 is remaining 15 units. Okay. Now we find the next minimum element from the all over the matrix. The third minimum most element is this 3. Okay. So this 3 is the next minimum element. So now we allocate here the minimum of x, what? This is the cell number x3 2, and this is equal to minimum of what? This 10 and this 5. Okay, so minimum of 10 and 5, so this is equal to 5. Therefore we allocate here 5 unit. Therefore the availability from the origin O3 is exhausted. This is exhausted clearly. Just a minute. Exhausted, and the availability from the demands for the destination D2 is now remaining. Just a minute. Okay, so now here we allocate what? Allocate the minimum of just a minute, 15. So here we allocate x32 equal to minimum of 10 and 5, and minimum of 10 and 5 is equal to what? This is equal to 5. Therefore we allocate here 5, and here the remaining demands for the destination D2 is 5 unit, and the availability from the origin O3 is exhausted. Okay, now we find the next minimum element, that is from the remaining element is I think 8, 9 and 7. Just a minute. Just a minute, this is hanging. So oh sorry, there is a mistake. x32 is equal to 3, but sorry, there is a technical issue I think. Okay, so the class is ends for this today. Okay, so in the next lecture I will discuss the matrix minimum method. Okay, there is some mistake, technical issue. Okay, so the class is end for this session, for this lecture. Okay, so thank you, see you again in the next lecture with matrix minimum method. Okay, so डिस्टर्ब कर रहा है ये थोड़ा, ठीक है. तो नेक्स्ट लेक्चर में मिलते हैं मैट्रिक्स मिनिमा मेथड के साथ. ओके, थैंक यू. And if the content is helpful, then please give a like to this video, share with your friends and subscribe this channel. Okay, thank you. मिलते हैं नेक्स्ट वीडियो में.